Hello everyone, today I want to explain the Mohr circle using two examples. If you keep watching to the end, I am sure you will fully understand from the Mohr circle technique. First, we have this example. Okay, I want to copy the example I have. Yes, then easily go to Google and write geometry GeoGebra. Okay, and Ctrl V. That is the example I have. And I want to also bring the explanation of the example. Now we have the stress 150 pound per inch square and the shear 60 pound per inch square. This direction we assume it's positive and this direction we assume it's negative. So we have to plot this point. First 150 and 60. From here point. Okay, 150 and 60. 150 and 60. That's the point E. And also, we have to plot 90 and minus 60. Now we can make it correct for EF. It is setting 150 and 60. Also for point E, 90 minus 60. Let it be name and value. Name and value. Yes. We can change this one also. Setting 150 and 60. Yes. Now we have to plot the circle. But first we have to create a segment which helps us to draw the circle. Now from circle, if you show more, circle with center, not circle with center and point. So from here, yes, that's our circle. The requirement, what's the requirement? The requirement, find major principal stress and minor principal stress. Now it is so easy to find major and minor principal stress. Just from here, if you zoom in, you will be more precise to determine the minor principal stress. That's H. And for major principal stress, yes. Now you can change some properties of these 2 points. From here, if you can copy this, search for row in Google, Control copy, and from here you can write V row 1 and name and value. Let it be color red. Also for this one, color red, and make it row 3, name and value. Yes. Now we got the solution. Minor principal stress is 52.9 and major principal stress 187.1 and shear is 0. Already we know that this axis is represent normal stress and this one shear stress. What's more we need? According to the requirements of the question, this one, major principal stress, normal, minor principal stress. Also, we have to know normal and shear stress on the plane AE. It's so important. On the plane AE. That's the plane AE. Okay. First, we have to create a pole. Pole is the originate of all the planes we have. How you can create a pole? From here, point. Pole is a point directly opposite for this one, or you can, if you draw a line from this point which intersect here, you can get your pole. It should be equal 90 and 60. So go to point H, settings, make it pole, name and value. Yes, that's the pole. Now to find the normal and shear stress on each plane, which is defined here, you just have to create a line parallel to this plane in this point. Now to find the normal and shear stress for plane ABE, easily you just have to create a line or a plane on the pole which is parallel to this one. So from here you create a segment. Yes. Now easily just bring this line to here. Yes. Now this line is parallel to this one. Okay. And draw a point on the intersect point. If you zoom in, you will be more precise or accurate. Okay, J. Just change the properties of point J, settings, name and value. Okay. Now you get the result 59.6 and 29.2. That is the normal stress is 59.6 and shear stress on the plane AE is 29.2. You see it's not too much accurate. Yes, now it's accurate. So normal stress on plane AE is 60.2 and shear stress on the plane AE is 30.3. That is the solution for example 1. Let's find the solution for another example. We have this question. This question has more requirement and I will explain it step by step. Let's open another one. Geometry GeoGebra. Open. According to the example, a sample of soil 0.1 meter multiply 0.1 meter is the area is 10 to the power minus 2 meter square is subject to the force shown in figure. That is the force. Determine minor and major and psi. And also we have to find the maximum shear stress and the stress on plane oriented at 30° counterclockwise from the major principal stress plane. In this example, if you learn, you will learn almost everything about the Mohr circle. First, we have to find the area because the force is given and we have to change force to stress, so we need area. To calculate the stress, we just need to just two simple steps. Step 1, the area of soil sample is 10 to the power minus 2 meter square, and calculate the stress. Rho z 5 divide the area, it will be 500 kilopascal. Rho x, you see this one in the direction of x, it will be 300 kilopascal. And shear in this one 1 divided by 10 to the power minus 2, it will be 100 kilopascal. Also shear in the clockwise, which is we symbol it as a negative, it equal also minus 100 kilopascal. Now we easily just draw and make a Mohr circle to find the solution for this question. Okay, yes, what's we need? 500, 100, 500 to 100. So that's 501. Draw point. Yes, E. The other, that's 500 and 100. Other 300 to minus 100. 300 to minus 100. Point. Yes. Let us see the properties. delete and property. Yes, it is good. Name and value and other. Yes, now so good, but we have to change to name and value. Yes. Now we need to draw a segment. It just help us to create a Mohr circle. Yes. Now from circle with center. Yes, that's the center. Yes. What is the requirement? First, we have to find major principal stress, minor principal stress, and psi. Psi, as I mentioned, it's an angle between the major principal plane and the horizontal plane. Let's find one by one. Okay, just create a point here easily, and here. Yes, change the properties for F and G. Setting, name and value. You can copy this. Copy row symbol, row 1, name and value. Change color to red. Yes. For F also. V, row 3, name and value. Change color to red. Yes. Now we found that minor principal stress is 258.6 and major 541.4. Also, the result depends on how much accuracy you put the points on the location. Also, we have to determine a pole, because as I mentioned, pole is the origin of all the planes. So point A, this one here, and change the property of F. Name and value, make it pole. Yes, as I mentioned it, psi is the angle between major principal plane and horizontal plane. So we need pole to create a major principal stress plane. So how you can create a major principal stress plane? Just connect major principal stress point to pole. Yes, this plane is a major principal stress plane, and horizontal plane, easily, this plane is a horizontal plane, and psi is the angle between horizontal plane and the major principal stress plane. Now easily from here you can determine the angle. Yes. Yes, that is the angle of psi. Okay, if we change, have ability to change, let setting, name and value, and I want to change. Yes, control copy, bring to here, right, and you can change color also to red. Yes, that is the answer for the first requirement. Now we found major principal, minor principal, and psi. Also we have to find the maximum shear stress. It's easily, you can find maximum shear stress just from here, point, as I mentioned it. Let us come to here, setting, y-axis, make it from 200, let be cross section 200. Okay, and create a point. Yes, change the property, name and value. Yes, but you have to make sure, not this one, 141. I think it's better to write tau max kilo Pascal. Change, it's wrong. And I can delete this point. Okay. Tau max 141.4 kilopascal. What is more requirement we need? The stress on a plane oriented at 30° counterclockwise from the major principal stress. Plane. It's important. We have to create a plane which is 30° oriented from the major principal stress. Plane. Okay, it's important. Yes. Okay, and measure. It is 37. Yes, 30°. Now easily just determine the point. Just determine this point of intersection with the Mohr circle, and change the properties of the G point, name and value. Now easily you see that the normal stress on the plane oriented with the major principal stress is 470.9, and the shear stress on the plane oriented with the major principal plane is 122.4 kilopascal. Also sometimes the requirement should be in this way. Say find the normal and shear stress on the plane which is oriented counterclockwise about 30° or 20° from horizontal plane. That is the horizontal plane. This time you can draw a line oriented from the horizontal plane with 30°. For example, maybe, okay, and bring angle. Yes, 26. Maybe it's say 20. Yes, you easily find the point here and change the properties of I. Yes, 412.5 normal stress and shear stress 140.9. In the next tutorial I try to find the same results by equation. That's all. I hope it can be helpful. Have a nice time.